Mechanical dewatering of municipal sewage sludge typically uses decanter centrifuges or belt filter presses. Depending on the upstream treatment processes, sewage sludge can generally be dewatered to between 15 and 25% dry solids. But a lot of water remains in the sludge to be handled in downstream processing or to be transported with the sludge to a landfill or land application. Increasing energy costs means transporting or evaporating water is becoming prohibitively expensive. So anything that helps to remove more water mechanically will give a substantial monetary benefit. Enter a new process developed by Flow Dry Engineering and now being commercialised by ElectroDehydro Limited of Auckland, New Zealand, that enhances the dewatering of sewage sludge. The process, known as EDH, uses electrokinetic effects to stimulate the removal of free and interstitial water from the sludge. Applying a DC voltage across a sludge matrix can induce an electro-osmotic flow which supplements the hydraulic flow caused by the pressure gradient in a belt press or the centrifugal force in a decanter and results in a higher dry solids content in the dewatered sludge. The EDH process works on the thin sludge prior to dewatering. Therefore, it's not dependent on the type or the make of the dewatering equipment and can be retrofitted into any manufacturer's equipment. The process was tested at pilot scale on a wide range of sludge types, including digested, extended aerated, SBR and MBR types. It was then taken to the Whangarei wastewater treatment plant for field trials. The earlier results have been verified in practice under full-scale processing conditions. Sludge from the storage tank was fed to 2 decanters in parallel. The pilot plant was connected to the sludge inlet pipe of one of these decanters. After treatment, the sludge was returned to the decanter inlet pipe via a pneumatic pump. Polymer for the dewatering process was injected into the suction side of this pump. A single-phase acid dosing pump was provided to add acid into the sludge feed line should this be required. Each electro-dewatering reactor module consists of a series of graphite plates with a clearly defined spacing and an appropriate residence time to allow the electro-dewatering effect to occur. In the pilot plant, each module handles 1 cubic metre per hour. A DC voltage of about 5 volts is applied across the graphite plates. Dewatered sludge normally has the consistency of cow pads and drops into the storage vessel with a plopping sound. It sticks to a shovel when lifted and turned. By contrast, the sludge to which the electro-dewatering effect has been applied is more friable. It falls off a spade more easily and can be held in the hand and crumbled. These visual effects are confirmed by tests on the dry solids content of the sludge. Almost all trials to date show an improvement over dewatering without EDH. A best fit curve of the results shows that improvements of at least 20% can be expected. Often the improvement is greater and could be for some sludge types as high as 40%. There are other benefits. It has been found that polymer usage is reduced when the EDH process is applied. Solids capture is not affected by the process and remains in excess of 95%. If the sludge is to be dried, then use of the EDH electro-dewatering process will dramatically reduce the operating costs of the thermal drying plant. Depending on the type of sludge, savings of between 25 and 40% in the hourly costs of dewatering and drying sludge can be achieved because of the reduction in the amount of water to be dried. The EDH process brings a dramatic improvement to sludge dewatering. Combined with the Flow Dry EnerSaver 2 drying process, it is revolutionising the field of sludge treatment. For more information on the EDH process, please contact ElectroDehydro Limited. Combining EDH electro-dewatering with Flow Dry EnerSaver 2 thermal drying is a key step to achieving a sustainable future.